From NBC4, this is News Conference with Conan Nolan.
On this edition of News Conference, a visit from the Consul General of Israel in Los Angeles, Jacob Dayan. As the Middle East undergoes tumultuous change, Israel is potentially redefining its relationship with its Arab neighbors. What does the future hold for America's enduring ally? What are the prospects for restarting the peace process with the Palestinians? And what will be the U.S. role? And is Hamas arming itself for more attacks? The crisis in Japan continues to unfold on multiple fronts. While heroic workers attempt to prevent further meltdowns at nuclear reactors, concerns grow about storage pools. And what about the radiation threat to the people of Japan and how much radiation has reached California? We'll talk with UCLA professor and nuclear safety expert Ivan Catton about the risks. Hundreds of Angelenos have been affected by the Japan earthquake and tsunami. Some have lost loved ones. This as thousands of Japanese continue to struggle with food shortages and lack of electricity and transportation. Our guest Brian Takeda from the U.S.-Japan Council will talk about the local impact and efforts to help. Welcome to News Conference. I'm Ted Chen, sitting in for Conan Nolan. Experts say it will take years to repair the reactors and resolve the issues raised by the nuclear crisis in Japan, which is ongoing. Joining us to discuss it is UCLA's Ivan Catton. He is a professor of mechanical and aerospace engineering and an expert on nuclear energy. Professor Catton, thanks for joining us. We appreciate it.
Thank you.
We in California have been assured all week that the radiation levels that we are receiving in California and in the U.S. are safe. Now, if this crisis in Japan escalates into the worst possible scenario, will that stay the case?
The incident is 5,000 miles away. And 5,000 miles in the atmosphere is a long ways. The level of radiation here will be essentially zero. I don't believe there's going to be any impact.
Okay. Let's talk about the spent fuel pools, which have been the focus of the concern in Japan, more so than the reactors right now. Why is that more of a concern than the reactors themselves, and what is the risk there?
There's several reasons that the spent fuel is of more concern. One is that it's not behind a big barrier. The reactor vessel itself sits inside a special containment, and it forms a cavity within which the reactor sits. So there's multiple barriers between it and the outside world. You have to penetrate the vessel. Once you've penetrated the vessel, you have to penetrate the inner containment. From the inner containment, you have to get out through the secondary containment. Whereas the spent fuel pool sits up on a high level, and there's only one barrier between it and the outside world. Now, they keep it covered with water, and as long as it's covered with water, it's not a problem.
The problem is if the cooling process does not continue. If those rods continue to not to be cooled, and we're not sure about the situation at this point, whether they are or not. Now, what is the risk if they are fully exposed?
Well, the risk is probably the same, if not greater, than the risk associated with the core penetration of the reactor vessel itself. You have more radionuclides stored in the spent fuel pool probably than there are in the reactor. Now, I haven't done the calculations, but just the amounts of fuel that are in the spent fuel pool are greater than are in the core.
And what about the possibility, and we're hearing this from the Japanese, of the resumption of fission in the core, too, that is a possibility if somehow the pellets collapse?
Well, my guess is that the pellets have certainly collapsed because the fuel is a zircaloy tube within which are pellets. And when you overheat the core, the zircaloy reacts with the steam and forms hydrogen, hence the early explosions. When those explosions occurred, you knew that there was damage in the core. Now, those pellets aren't going to stay in a big, tall stack. They're going to fall. When they fall, they block flow. That leads to melting.
Okay.
So I think there was core melting very soon after the hydrogen explosion, if not before.
And what is the risk at that point that the partial core melting will evolve into a full-scale core melting, which is everybody's fear?
Well, if they would not have gotten cooling, the risk would have been very high.
And the cooling is troublesome right now, and not being able to put the helicopter drops and also delivering the water cannons.
We're mixing two things up. If you're talking about the core, they took care of the problem. At least the what I've been hearing, all of the reactors, they've established cooling for the core. Now, the spent fuel pool is another story. They have not established cooling. They did try to use the helicopters, but the wind blew it away. What I don't understand is you watched the firefighting here, and they're pretty accurate with those things. Yet when I watched the helicopters flying over the spent fuel pool, they just seem to be throwing the water anywhere.
If those rods are fully exposed and they aren't able to be further cooled, then what is the risk to the people of Japan and the people who live in that immediate radius?
The risk is certainly higher. And the risk to you as a person in a given location is going to depend strongly on what the meteorology is at that particular time. If you've got a wind that's blowing everything all over the countryside, it's going to reduce it because you get dilution. But there's still going to be problems. If you have a cesium uptake or whatever, you can have severe problems. That's where maybe mentioning Chernobyl, they literally blew it apart. And yet the number of deaths was relatively low.
This is being described as a crisis in between the levels of 3 Mile Island and Chernobyl.
And it certainly is.
How much of a risk is there of reaching a Chernobyl level or beyond?
I don't believe you can reach a Chernobyl level. Because Chernobyl, there was an actual explosion that dispersed everything. Where you're not going to have that here. What will happen is you're just slowly going to degrade this system. It's going to heat up. And things are going to boil out of the core. And get caught up in the wind and carried away. So if they do the evacuation from the area, they probably can avoid much risk to people. There may be risk to agricultural land in the vicinity.
We use the same type of storage pools, same temporary storage for these fuel rods in California, in San Onofre and Diablo.
Well, there is a bit of a difference.
Okay, what is the difference?
The difference is that both Diablo Canyon and San Onofre are pressurized water reactors. Now, I'm not sure, but I believe that the spent fuel pool is inside the containment. So this gives them much more protection. The containment has spray systems and all sorts of things that can help them clean things up.
We've been told repeatedly from officials at San Onofre it's built to withstand a 7.0, which is the likely maximum scenario for an earthquake here. It's got a 30-foot tsunami seawall. But I don't think a lot of people were expecting a 9.0 in Japan either, and I think that's what makes some people nervous.
Well, Japan was expecting an 8.1, so they got a earthquake that was 10 times. Now, if you got a 9 here, that would be 100 times the design basis. And the NRC is taking a look at the design basis earthquakes for all of the plants in the U.S. And they've actually compiled a list of what it should be. And some have gone up, some have gone down. And they have also asked that each plant has to reevaluate its design basis. If you do that, you do whatever it is that's necessary to bring your plant up.
Okay.
Now,
Professor,
you need to make sure the design basis accident, you reach whatever it is in a responsible way.
Professor Ivan Catton from UCLA, thank you so much for coming in.
Thank you.
We appreciate it.
Thank you.
Up next, the Consul General of Israel in Los Angeles talking about Middle East peace and the new Arab world.